Welcome to our discussion on project risk analysis and decision making, from EMV to business continuity in a project. In our earlier discussions on project risk management, we look at the identifying and assessing risk. In this presentation, we are going to take that discussion one step further and look at how we can use quantitative information to make better project decisions. We will focus on expected monetary value, or EMV, decision tree analysis, contingency reserves, and finally, business continuity in a project context. The important connection throughout this presentation is this. Once we identify uncertainty, how do we use that information to make a better project decision? So let's begin with the relationship between uncertainty, risk analysis, and decision making. So every project operates under some degree of uncertainty. When we develop a project plan, we are making assumptions about cost, schedule, resources, suppliers, technology, and many other factors. But we know that actual outcomes may be different from what we plan. As project managers, we still have to make decisions even when the outcome is uncertain. Risk analysis helps us answer three basic questions. First, what could happen? Second, how likely is it to happen? And third, what would be the impact if it happens? Notice the progression shown at the bottom of the left side of the slide. Uncertainty leads us to risk analysis, and risk analysis helps us make a more informed decision. Risk analysis does not eliminate uncertainty. Instead, it gives us a better information for making decisions under uncertainty. There are several quantitative techniques that project managers can use to analyze this uncertainty. Monte Carlo is a computer software which uses high numbers of repeated random samples to obtain numerical results. If you are developing a project schedule using the critical path method, for example, Monte Carlo can generate thousands of possible start times for all the activities and produce a range of possible critical paths. Sensitivity analysis is a technique to analyze the potential impacts of identified risk. It represents the impact of threats and opportunities. You can also perform a sensitivity analysis by considering each risk in isolation. Decision trees are used to support selection of the best of several alternative courses of action. Alternative paths throughout the project are shown in the decision tree using branches representing different decisions or events, each of which can have associated costs and related individual project risk, including both threats and opportunities. The endpoint of the branches in the decision tree represents the outcome from following that particular path, which can be a negative or positive. Expected monetary value, or EMV, measures the probability weighted monetary impact of an uncertain event. The basic formula is very simple. EMV equals probability times monetary impact. For a threat, we normally represent the financial impact as a negative because it creates an additional cost or loss. For example, suppose that there is a 30% probability of a $10,000 loss. 30% times negative $10,000 gives us an EMV of negative $3,000. So now look at the opportunity. Suppose there is a 20% probability that we can save $15,000. 20% times 15,000 gives us a positive $3,000 EMV. One point I want you to remember. EMV does not mean that the project will actually lose or gain $3,000. The actual event may occur or it may not occur. EMV gives us a probability weighted expected value that we can use for analysis and decision making. Now let's see how EMV works in a decision tree. So let's start with a simple example. Suppose we have two possible business decisions, open a bike shop or open a clothing store. The bike shop has a potential income of $400, while the clothing store has a potential income of $600. At first glance, you might choose the clothing store because $600 is greater than $400. But we haven't considered risk yet. For the bike shop, there is a 50% probability of success, producing $400, and a 50% probability of failure, resulting in a loss of $150. So, um, so we calculate 50% times $400 is equals to $200. Then 50% times negative 150 equals to negative $75. Add those together, $200 minus $75 gives us an EMV of $125. Now let's do the clothing store. 50% times $600 equals to $300, but failure results in a $400 loss. So 50% of times negative $400 equals to negative $200. $300 minus $200 gives us an EMV of $100. So which alternative would we select based solely on EMV? The bike shop, because its expected monetary value of $125 is greater than the clothing store's $100. This illustrates why we cannot simply look at the largest possible payoff. We also need to consider the probability and consequence of the possible outcomes. So let's apply the same concept to a more realistic project management decision. So here we have a project decision about whether the company should build a prototype. If the company prototypes, there is an initial setup cost of $200. There is then a 35% probability of failure with a $120 impact. Let's calculate the risk exposure. 35% times 120,000 equals to 42,000. We then add 200,000 cost of developing the prototype. That gives us an expected cost of 242,000. Now let's look at the second alternative. Do not prototype. There is no initial setup cost. However, without the prototype, the probability of failure increases to 70%. And the impact of the failure is much greater, $450. 70% times 450,000 gives us an expected cost of 315,000. So we compare prototype 242,000, do not prototype 315,000. Since this represents cost, we would normally prefer the lower expected cost. Therefore, based on this analysis, prototyping is the better alternative. Notice what we have done. We have taken the uncertainty and converted it into information that can support a project decision. But EMV isn't useful only for choosing between alternatives. We can also use the same concept when planning for project risk exposure. This brings us to the connection between EMV and contingency reserves. Look at the process shown on the slide. We begin by identifying the risk. For each risk, we estimate its probability. Then we estimate its monetary impact. Probability times the monetary impact gives us the EMV. When we calculate the EMVs for our identified risk, we can aggregate those values to estimate the project's overall financial exposure. That information can then help us determine an appropriate contingency reserve. Remember that the contingency reserves are intended for identified risk, the risk we often refer to as known unknowns. Threats increase expected cost exposure, while opportunities cost can reduce expected cost exposure. So let's work through an example. Here we have 5 identified project risks. Some are threats and some are opportunities. So let's calculate the EMV for each one. Risk number 1, there is a 30% probability of a delay in receiving parts with 9,000 cost impact. 30% times $9,000 equals to $2,700. Because this is a threat that would increase our project cost, we show it as a positive 2,700 of expected cost exposure. Risk number 2. There is a 20% probability that the parts will cost $10,000 less than expected. So 20% times 10,000 equals $2,000. But this is an opportunity. It saves the project money. Therefore, we subtract the $2,000. Risk number 3, there is a 25% probability that the two parts will not fit together, resulting in an additional $3,500 cost. 25% times $3,500 equals to $875. This is another threat, so we add it. Risk number 4, there is a 30% probability that manufacturing will be simpler than expected, saving $2,500. 30% times $2,500 is equals to $750. Again, this is an opportunity, so we subtract the $750. Finally, risk number 5, there is a 5% probability of a design defect causing $5,000 of rework. 5% times 5,000 is equals to negative $250, which equals to $250, which we add because it is a threat. Now, we aggregate the exposure. 2,700 minus 2,000 plus 875 minus 750 plus $250. That gives us a total expected cost exposure of 1,075. In this simplified example, the aggregate EMV provides a basis of 1,075 cost contingency reserve. The key idea is not just the arithmetic. We are using information about identified risk to make a more informed decision about how much contingency should be included in the project. So far, we have looked primarily at the individual risk, but what happens when a disruption is large enough to affect the ability of the project to continue? So this takes us from an individual risk analysis to business continuity in a project context. Here we're asking a different question. If a major disruption occurs, how do we keep critical project activities moving, or how do we recover them as quickly as possible? The process begins by identifying the project critical activities. Next, we analyze the possible disruptions, risks, and impacts. Then we prioritize the critical work and dependencies. In other words, what absolutely needs to continue and what other activities depend on it. Next, we develop continuity strategies. If the disruption actually occurs, we activate those strategies, respond, and recover. Finally, after the disruption, we review what happened, capture the lessons learned, and improve our plans. Let's use the scenario at the bottom of the slide. Suppose a major typhoon closes a construction site for 2 weeks and disrupts deliveries from a primary supplier. The project team may already have identified continuity options, an alternative supplier, resequencing activities so others can continue, remote project coordination, backup communication systems, or emergency contracting procedures. Notice that we are not saying the project will operate normally during a normal disruption. The objective is to protect critical project activities and enable the project to continue whether possible or recover more effectively. And that brings all the concepts in this presentation together. So let's bring together the discussion in today's presentation. We started with expected monetary value, which helps us qualify the probability weighted financial impact of uncertainty. We then use EMV in a decision tree analysis to compare alternatives and determine which choice provides the better expected outcome. Next, we saw how EMV can help quantify identified risk exposure and support the development of contingency reserves. Finally, we moved beyond individual risk and considered business continuity, how critical project work can continue and recover following a major disruption. Together, these concepts contribute to the project and organizational resilience, the ability to adapt, recover, and continue delivering value. And remember this final point. Risk management cannot eliminate uncertainty. What it can do is help us understand uncertainty, prepare for it, and make better decisions when it occurs. Thank you very much for listening.